Alright, here we have opened up my current model, which I have the car chassis following the NURBS curve. And I also have a plane with dual colored blocks just as a reference. However, you look at it and you say there's quite a bit going on here, and there is quite a bit going on here. However, to skim the surface, I have all of my original parts over here, and I decided to use some tires that I built in a tutorial just because of the rubber deflection. That way I could get a good idea and play around with it, as the default tires on the car that I made originally don't have much room. Anyhow, you get a good idea of the plane in the middle. It acts more or less, once it's rendered, this red plane right here is going to be invisible. You're not going to be able to see it. However, in the model, as you saw before, you need to have some sort of a mesh or whatnot to follow the actual curve. And what I have here is the mesh in here following the curve, and the body, the wheels, all parented to this mesh. And once the mesh is rendered, you will not be able to see it. And as I said before, the car body, the front and rear axles are parented to this mesh separately. In here you can see the actual curve that is created by the car, and it's fairly linear. However, if we get down on the side here and you look at the wheels I have now moving. If you can see the Z and Y axis arrows moving, the car is in fact moving, and the wheels are moving in correlation with the speed that I have set within my IPO curve editor. And you can see here that you can set different speeds for different vertices on the curve, and also specify where you want the X and Y vertexes. I don't really want to mess around with that right now. However, this is a perfect example of what I was saying before. It's an unbelievable tool for controlling specific objects or models, individual or in relation to another movement of another body or object. And what I have here is the wheels moving in proportion to the forward speed of the parented mesh in here. And if I play this, you can now see that the wheels are in fact moving. And it makes its way around the track. And I also, like I said before, have I've been playing around with wheel tilt and tire deflection, and you can see right in here the wheels do tilt. I probably won't include that in my final rendering. You don't really need it, but it was fun playing around with it, with the lattices and whatnot. Anyway, we'll finish that, and once I render this, as I said before, you can't see the internal mesh in here. And right now I have just the chassis mounted onto the parented mesh, so I can see what's going on, as I had everything together and it was a nightmare to get into the two front and rear axles and to actually plot the points on the IPO curve editor according to the mesh. So I left everything open so I could edit it easier. However, a quick rendition of this. Let it go through. And after it renders, we will see a nice animation of the rolling chassis along with wheel tilt, which I will probably do away with. And if you haven't noticed, I also included the camera to follow the mesh at a certain distance, and I applied certain rotations around the corners to make it look more dramatic. But as you can see, it is an excellent effect, and other than learning about the lattices, it was fairly straightforward. I looked at some tutorials, and with the wheel tilt and the deflection, it really helped me put everything together. But parenting the mesh to the front and rear axles to follow the curve was probably what made it the easiest to understand, because like I said before, we can match the forward motion of the mesh to the rotation of the tires individually. Obviously all the tires are moving at the same rotation. However, it made it extremely straightforward and much user friendly to do it this way.